We're verifying trig identities today. So we're going to do 3 problems, and I want you to go through and pause the video and then watch to confirm that you did it right. So, also there's more than one way to do these problems, so if you end up with what I have in the end, you probably did it right. Okay? So the first one, tangent x plus cotangent x equals secant x cosecant x. All right, more complicated side. Probably with the addition. Okay, so I'm going to use some properties to get everything in terms of sine and cosine on the left-hand side. So tangent is the sine of x over the cosine of x. Cotangent is cosine x over sine x, and that should equal in the end secant x times the cosecant of x. All right, looks like we need a common denominator to add fractions, so I'm going to multiply by cosine x, and I'm going to multiply by sine x on the top and the bottom. Okay, so different forms of 1. Sine squared x over sine x cosine x plus cosine squared x over sine x times cosine x is equal to secant x cosecant x. How do I add fractions? Well, I need a common denominator. I have one. Yay! Common denominator. Sine x times cosine x. And on the top, I have cosine squared x plus sine squared x. And that equals secant x cosecant x. I see that this Pythagorean identity right here, cosine squared x plus sine squared x, that's equal to 1. And that's over the sine of x times cosine of x is equal to secant x times cosecant x. I can split apart fractions. So, I can do 1 over the sine of x times 1 over cosine of x is equal to secant x cosecant x. So when multiplying, I just multiply the top and the bottom, so we can just split this. Okay. So, and what's 1 over sine? Well, that's cosecant x. And what is 1 over cosine? Well, that is secant x. And that equals secant x cosecant x. All right, and so we're verified. Done. Okay, so some tricks for you. Always work on the more complicated side. Okay, use factoring rules. So like GCF, perfect squares. We want to rewrite things in terms of sine and cosine. Convert everything to sine and cosine. Okay, and then if you get stuck, just start over. Like cross it off and start again. I would cross it off so you remember what you've already tried. Okay. So number 2. Go ahead and pause the video and then and then come back to see if you did it right. Okay. So the more complicated side, we're going to start on the left. Secant squared x, or theta minus 1 over secant squared theta. Secant squared theta is tangent squared theta using Pythagorean identities over secant squared theta, and we're going to hope that equals sine squared theta. Okay, rewrite tangent using quotient properties, so sine squared theta over cosine squared theta all over. How can we rewrite secant squared theta? Well, 1 over cosine squared theta. And we're going to equal that to sine, hoping it equals sine squared theta. Okay, so multiply by reciprocal, cosine squared theta over 1. Okay, looks like those cancel, leaving us with sine squared theta equals sine squared theta. Verified.